Hello. So in this video, I'll talk about the satellites and rockets. So talking about the satellites, what are the satellites? Anything which revolves around any body, particularly in the space, is known as the satellite. Okay. For example, if I talk about the Earth, so Moon is the natural satellite of Earth. Okay, because it is natural, it is revolving naturally, and it was already present in the space. Now, apart from this, what we do, we launch a lot of the satellites. Now, the purpose of the satellite could be different. Okay, so for example, a satellite can be launched for the observation. The satellite can also be launched for the communication, communication. Okay, and for any other purpose. Okay, so the purpose of the satellites depend upon your uses. Now the question arises that how we launch the satellite. If satellite is not already present in the space, so how we launch the satellite? So for that we have the rockets. Okay, we have the rockets, and the latest rocket that we have for now is the PSLV. Okay, known as the Polar Satellite Launch Vehicle. Okay, or we can name it as the, for example, PSLV PSLV Mark 3. Okay, maybe you have already heard this name, and this is also known as the LV-M3. Okay, launch vehicle Mark 3. So in this video, what I will going to talk about, I will talk about why these rockets are only known as the PSLV. Okay, and what is the specific use of the PSLV, why we use PSLV. Okay, next is why in the PSLV there are multiple engines. So as you can see in the PSLV, okay, if I show you the diagram, so you can see here there are four engines in the PSLV. So this one is the first stage engine, this one is first stage engine. Next, this one is the second stage engine, and this is the third stage engine, and this one is the fourth stage engine. And here in this part is the carrying the satellite. Got a point? So what is the purpose of these different stage engine? We're going to look into details of it, and we will also talk about the payload capacity of the PSLV. Payload capacity of the PSLV, the type of the fuel it contains. Okay, solid, liquid. तो इसके बारे में बात करेंगे that what different kind of the fuels it has. Okay, solid, liquids. Now, what is the significance of the solid fuel? What is the significance of the liquid fuel, and why every time at the last it is liquid only? Okay, next we're going to look at what are the cryotechnology and how this cryotechnology is related with the last stage liquid engine or liquid fuel. Now, why the last stage is always liquid, as I was talking about. Okay, and we'll talk about the cryo engine, and simultaneously here we will talk about the functions of the impulse, that what is the functions of the impulse, okay, in the placement of the satellites at the designated or predetermined orbit. And later on we'll talk about the various types of the PSLV and its applications in the day-to-day life or in the space technology. Okay, next, so talking about, first of all, so this is all the data. I will go through this data and whatever different types of the PSLVs and all these things. Okay, but before that I want to convey a message. What I want to tell you, the details of everything, that how the satellites are launched. Okay, so first of all we'll have the basic understanding of the satellite, the basic understanding of the gravity, and then later on I will talk about the details, that how many PSLV we have launched, how many PSLV got failed somehow. Okay, what is the latest PSLV that we have launched recently? So we're going to talk about the details of these things. So first of all, let's have some basic understanding about the rockets and the PSLV. So if I talk about the PSLV or the rocket, so this is our Earth, the Mother Earth. Now, in the Mother Earth, okay, in the Earth, there's a concept known as the gravity. Gravity. Now, what is gravity? Gravity is anything which attracts you towards it. Okay, so you know that in the center of the Earth, the lot more mass is there. Lot of the metals are there, and because of these things and because of the some more phenomena, it's add to the concept of the gravity. So whatever is up there, it will attracted by the gravity. Okay, now as we launch the rocket, So first of all, we'll address the question, the why only the polar satellite launch vehicle. The first question. Now, so first of all, if I talk about the satellite, so as we launch the satellite, if we are launching the satellite from here, if we are launching the satellite from here, so the force is on the gravity is equal to g mm by r square, g mm by r square, and you know that the radius of the earth is near about 1400 kilometers. Okay, okay, of the, you can talk about the polar radius. Okay, so now the r is very less, so as much the r will be less, the more will be the gravity. Okay, so initially you need a lot of thrust, initially you need a lot of thrust, and then it will go around. Okay, now talking about why we have named it as the PSLV polar satellite launch vehicle. Now if you launch the satellites near the equator, let's say one satellite is moving around that, okay, near the equator, so there's a difficulty. If this is the sun, if this is the sun and sun is casting its ray, so there'll be one point come where the satellite will be in the shadowy region. Let's say the satellite is here in this part. Now the satellite is in this shadow region, and hence throughout the process, means let's say for example 24 hours there. Okay, so in the whole time it will only work, or we can just transmit the data only, or we can see the things only in 12 hours. Got the point? So what we do for the communication purpose, what we do, we launch the satellite in the equator, because there we don't need any pictures of the earth. But if we want the observation of the earth, so observation can only be done in the light. Okay, so hence PSLV is also known as the polar satellite launch vehicle. These satellites are also known as the earth observation satellites, earth observation satellite, or you can also call them as the remote sensing satellite, remote sensing satellite. Clear? Now, so this thing has been addressed, that PSLV क्या करती है, what it do, है ना, what it do, it launches the earth observation satellite. Now the next question arises, that what is the use of the multiple engines or the payload capacity. So first I will talk about the use of the multiple engine. So talking about the use of the multiple engine, what I have told you, that initially, let me just erase it for you. Now, initially what happened, as I told you, when the rocket will be launched from this side, okay, and you know it very well, and I'll explain this concept later, that most of the rockets, they are launched, if we are launching here, they are launched from the eastern coast. Why from the eastern coast? Because Earth moves from west to east in this direction, from west to east. Okay, so that it can have the initial push. To have the initial push, it is launched from the eastern coast. Okay, eastern coast. Okay, for example, in the case of the India, for example, the recent we have made in the Kula and then later on, before that, we have the polar the Satish Dhawan Space Center. Okay, na, Andhra Pradesh. Clear? So what happened was, first of all, if I talk about the rocket, okay, na, let's say the rocket. So in this is the solid, then it's liquid, and then it's solid, and then it's liquid. Let's say for example for the PSLV, these are the 4 categories. Now what I told you, initially we need a lot of the thrust. We need a lot of power. Why? Because there's a lot of the gravitational pull, because the radius of the earth is small. Okay, or r is small. As much as r will be small, the g will be greater. Now what happened with the solid fuel? Whenever the fuel is very much compact, it gives a lot of energy. Clear? Next thing, so one thing is the fuel is very compact, the particles are very close. Next thing, there's a problem with the solid fuel. What is the problem with the solid fuel? That you don't have the control over the ignition of flame. Let's say for example, if you have a coal, you burn the coal, and coal is burning. Now at that time you cannot lower down the flame or increase the flame, है ना? It will burn itself. You cannot do anything on it. Clear? So in the same manner, if we have a solid fuel, if we have a solid fuel, so we don't have what? We don't have the control over the fuel. So it will burn. It will burn at the very high flame. Okay, we don't have the control. For example, you have the petrol car. So petrol car is what? It is a liquid engine. Now here you can turn on and turn off the engine. So it gives you the maneuverability. Okay, it gives you maneuverability, or it gives you control over the engine. But initially we don't need a control. Initially, or when we are launching the satellite from here, or we are launching the rocket from here, we don't need control, है ना? Because we want that it flow with a lot of the impulse, clear? Hence we use solid fuel. For example, for the purpose of the solid fuel, we carry the fuel like the HTPB, hydroxyl terminated polybutadiene. Clear? Now comes why the last stage is liquid. So the last stage is liquid. Okay, the last fourth stage is mostly liquid. Why? Because the liquid gives the maneuverability or the control. Why? For example, you know, we have launched the satellite, you know, and satellite is on this orbit, then it moves to the higher elliptical orbit, and then more higher elliptical orbit, and here I want to place my satellite. So in this condition, what I need to do, first of all, I'll burn the solid fuel, I'll place the satellite here, then it will move around, and I'll further place the satellite in this path, and next in this path. So here I need what? Here I need the control over the engine. Let's say my satellite has come in this orbit, and to jump from here to here, first of all I need to switch off my engine. But if I have here the solid engine or solid fuel, clear? So I don't have the control over the engine. So hence mostly the last stage is liquid. And here comes the concept of what? Here comes the concept of the impulse. And you know it very well. These are the 4-stage engine. But what we do, look, if we have only one engine, there will be a problem with this solid and liquid engine. Clear? Because a lot of the energy is there in the solid, but a lot of the control is there in the liquid. So this is the main problem. Next, for example, if we have very big one size engine, so what next problem will be, if we are here, for example, we are here or we are at this orbit. Clear? Now the rocket, okay, on which we are carrying the satellite, which is carrying the fuel. Okay, so basically it is empty totally, or it is more than half is empty because we have exhausted the fuel. Now we are without any purpose carrying the bulky engine. So we remove that engine. So what happens if we are done with this stage first? We remove. It gives what? It gives us free hand, or our rocket become light and generate more power. And here comes the concept of the impulse. Now what is impulse? Impulse is equal to F into T. Okay, force into time upon the weight. So it is what? Impulse is, ठीक है ना? Impulse. This is impulse. Not weight is there. F into T. Next इसके बाद concept होता है specific impulse. And here I will talk about the F into T upon weight. What it means? It means that if your weight is less, your impulse will be more. Clear? The impulse will be more. And the impulse is more. With the liquid engine or with the liquid fuel. With the liquid fuel, the impulse, or I should call the specific impulse will be more. Clear? Now here comes one more thing, is the cryotechnology or cryo engine. Now what is it? Now you know it very well. Let's say for example we have the hydrogen gas. Now if we going to compress this gas and make it liquefy, okay, make it liquefy, it become liquid hydrogen. In this time now the hydrogen liquefies near about 250 degree Celsius, minus 250 degree Celsius. So anything which is at the very low temperature is known as the cryo. Now this liquid hydrogen has more power than the liquid gas hydrogen. This liquid hydrogen has more power than the gaseous hydrogen. Now what we can do, we can make a cryo engine. Okay, we can make a cryo engine. How? We can make a cryo engine by how? So we can have liquid hydrogen and we can have liquid oxygen. Because to burn this hydrogen, we need what? We need oxygen. To burn this hydrogen, we need oxygen. And what I told you that liquid fuel gives the a very great impulse. Talking about the best impulse, from where we can have the best impulse, and why we are focusing only on the impulse, because impulse gives us control, a lot of control over the engine to be placed at a particular orbit. Got a point? So here is the best impulse will be provided by this cryo engine, this cryo engine. Clear? Now talking about the fuel. Okay, talking about the fuel. So the weight of the PSLV. If I talk about, for example, if I talk about the PSLV weight, so the weight of the total PSLV is the 3 lakh kg, or you can say it as the 300 tons. Clear? Now the weight of the satellite, it is only near about 1800 kg, near about that only. Clear? Or in that, even in 3 lakh, in this 3 lakh kg, on this 300 ton, in this 80% is fuel only. 80% is fuel only. Hence it is needed more that we remove the engines in the later on stage. Clear? And what is more specific, or what is more important, or what is the characteristics of this cryo engine, that it is light also in compared to this liquid engine also. Because there's a liquid engine, there'll be more of the pipes. Clear? More of the pipes, lot of the pipes will be there. Clear? Okay. And obviously liquid has more density than the gas. Okay, so there'll be more number of molecules. So these are the reasons why we are using different stage of the rocket, first of all, and different type of the fuel. Got it? And maybe you have got the mostly probably you have got the concept of the payload different type of fuels. So talking about the multiple engine, we have talked about it. Okay, na? Next, what we have talked about, I have talked about the payload capacity. That overall the PSLV, it has the 3 lakh kg or 300 tons. In it 80% is fuel only, and the weight of the satellite, it is only 1800, near about, or 1850 kg. Now why different types of the fuel? We have talked about it. Technology, we have talked about it. And why last stage is always liquid? Because it gives us the maneuverability, or it gives us the agility to have the control over the last stage, the rocket. Okay, and so that from this control we can place the satellite at the predetermined or desired orbit. Next, cryotechnology, we have talked about it. Now types of the PSLV and its application. Now we are jumping on the data, so that we can have more insight regarding the PSLV. Okay, so talking about the PSLV, so I'll read and I'll explain some of the things from here. So basically these are the 3 broad categories that we have developed over the period of year by these two. So PSLV is there, GSLV, and the sounding rockets. These are the broad categories. Okay, these are the broad categories. So talking about the PSLV, okay, so it is a third generation satellite launch vehicle. What it means by the third generation? So ISRO, till now, ISRO has developed 5 generation of the rocket. First is the SSLV, ASLV, and then the third is the PSLV and the GSLV. Clear? And then the GSLV Mark 3, which is also known as the LVM3. Clear? So this is the third generation. From the third generation was first, second, and from the third. And this was the first time in the third generation, है ना, in the third generation this was the first time that this engine is equipped with the liquid stage. And liquid stage that gives what? It gives the maneuverability, it gives the agility, it gives the sophistication to have the control, है ना. So anytime whenever we want we can turn on and turn off the engine, which can saves our fuel also. Clear? And even right now what we are doing, we are using the reusable, है ना, reusable launch vehicle, है ना, where the satellite, where the rocket, it will come back on the earth. So we can, है ना, we can reduce the space garbage also, and we can save our money also, है ना. It will have less impact on the body, on the money, on our pocket. Now where is the PSLV is used? यूज कहाँ करते हैं, है ना. as I told you कि if we are launching the satellite on the poles, है ना, तो it gives the light 24/7. Okay, it gives the light 24/7, and it also gives, from that light we have the ability to observe the earth properly. And otherwise if it is there near the equator, what will happen? Half the time it will be on the shaded area, है ना, dark रहेगा, it will be difficult to observe then. So it is used for the earth observation, है ना, or Indian remote sensing satellites. Clear? Remote sensing satellites, you know, this is the whole picture. Now one more thing is there I want to tell you. First of all, the first vehicle we have launched, है ना, we have developed it in 1990s, and the first we have launched in 1993, and it was a failure. So first successful was in the 1994, ठीक है ना, 1994. So 60th we have launched, the 60th we have launched on the January 2024. It's 2024, ठीक है ना. The mission name is the PSLV C58. Now why the numbering C58 and the mission is numbering is C58, and I'm saying it is 60th launch? Why? Because earlier 2 launches were failure terms or culminated into failure, ठीक है ना. और इसके बाद आया था later on comes the PSLV C59. PSLV C59. So this PSLV C59, this is 59 in the series, and the mission was the Proba 3 mission, and it will launch on the 5 December 2024, and it was the 61st mission, but it is 59 here because the 2 were culminated into failure. Okay? The payload capacity I have talked about. One more thing I have talked about, that what is these things, ठीक है ना, what is these things, ठीक है. So these are what? These are the additional motors. These are the additional motors, ठीक है ना, and this is known as the strap on motor. Strap on motor. What is the function of the strap on motor? So it gives what, ठीक है ना, it gives more power. For example, if there's only rocket, ठीक है ना, if there's only rocket, ठीक है ना, and this rocket is launching the satellite. So in this condition what will happen? The payload of the satellite could only be near about 1100 kg in the SSPO. But with these strap motors, it gives more power, and we can carry the satellite weight up to 1800 or 1750 kg. है ना. These are the strap motors, है ना. These are the strap motors. और होता क्या है ओवरऑल, है ना. ओवरऑल क्या होता है ओवरऑल? If I talk more, so there are different types of the PSLV. If I talk about the types of PSLV, ठीक है ना. So there's for example PSLV XL, है ना. For example PSLV 5 is there, ठीक है ना, and this PSLV XL is there. PSLV G is there. ये सब क्या है? For example PSLV V जो है, ठीक है ना, ये क्या होता है? This is core alone, ठीक है ना. इसकी जो सैटेलाइट कैरिंग कैपेसिटी होगी विल बी 1100 ओनली, 1100 kg. जो PSLV एक्सेल है, ठीक है ना, इसमें क्या है? इसमें 6 this has 6 extra large strap motors. What I have just shown you, strap motors, ठीक है ना. So this will give more power, and we can carry more satellites, है ना, or we can carry the increased weight of the satellite, 1850 kg. Okay, in the same manner PSLV G, it has 6 strap-on motors. Next is the PSLV QL. it has the 4 to 5 strap-on motors. PSLV DL, it has 2 to 5 satellite motors, okay, or strap-on motors. So these are the various type of the PSLV. Depending on the strap motors, it can carry the weight. Clear? So PSLV, it is what? It is 4-stage, है ना? 4-stage, uh, 4-stage rocket, solid, liquid, solid propulsion alternatively. ठीक है ना? Okay, and it has, as I mentioned already, it has 6 solid rocket strap-on motors. Strap-on motor I have explained, and it gives a lot of the thrust initially, because at initial position it needs a lot of thrust to overcome the effect of the gravity, because the R is very small, hence the G is very large, small g, and the capital G and a gravitational constant will be constant everywhere. So talking about some achievement of the PSLV. So talking about the reliability, it faces the failure only twice in 3 decades. 60 launches it has done, है ना? 61st I have mentioned only, December वाला, ठीक है ना? And apart from that, we are also using the PSLV for the commercial purpose. We have also launched near about 350 satellites in the 34 different countries. ठीक है ना? We have completed the missions like the Chandrayaan MOM and the IRNS, Indian Regional National Satellite System, है ना? Navik, maybe you have heard Navik. Navik is, it is the, you can say that Navik is the GPS of India. GPS is Global Positioning System. This is of US Navy. ठीक है? Then it is also strengthening the soft power, because we are launching the satellites of the different foreign countries, है ना? And apart from that, the scientists are also doing their from the data that they are receiving from this PSLV, they're also using in the non-space application. For example, the fire resistance tiles, better engineering for the missile technology, and lot more state-of-the-art technology purposes. So in this video, what I have talked about, I have talked about the satellites. Again, I have talked about the satellites, I have talked about the rockets, PSLV, why the PSLV, only name the PSLV, what are the multiple type of the engines, okay, why we have the different stages of the engine, okay, what is the payload capacity, okay, near about the 3 lakh and 300 tons, in which 80% is the fuel only, okay, and what is the use of the last stage, or what is the significance of the last stage liquid engine, okay, what is the cryo technology, okay, and what we have talked about the cryo engine, and I have talked about the PSLV and its application. So I hope you have liked this lecture. If you have liked this lecture, do let me know in the comment section. Till then, take a goodbye. Thank you. Jai Hind.